Hi, everyone, and welcome to Seed Speaks today. This is a video series brought to you by Seed World Group. I'm Mark Zankowitz, and I'm an editor with Seed World Group. And this month, we're talking about all things related to weather. I am joined today by two people who can definitely speak to the issue of weather as it affects our industry. Austin Dobbles is a corn breeding project specialist at Syngenta based in Malta, Illinois. He has a huge interest in drones and has studied how they can be used for high throughput phenotyping in crops like soybean when it comes to things like iron deficiency, chlorosis. At Syngenta, he's part of a team with the task of developing corn hybrids, and he has responsibilities related to inbred line and commercial hybrid corn development. How are you today, Austin?
I am fantastic. Great to see you after what? It's been 5 years since I last saw you.
It's been a while. Yeah, we met in Guelph, Ontario, and I guess in 2018 at the National Association of Plant Breeders. So nice to see you again, sir, and
Yes.
thanks for being on today. And our second guest is Jim Ellington. He is CEO of Arable based in San Francisco, California. Jim is the former VP of product at the Climate Corporation, where he helped build Climate Field View, which is the most widely adopted digital ag solution on the market. As CEO of Arable, Jim focuses on product iteration, team building, and scaling up the go to market for this decision agriculture technology company. Jim couldn't be on live today, but I recorded a short chat with him last week. And we're going to play some snippets from that during our chat, Austin. And today, Austin, I wanted to discuss digital agriculture, precision agriculture technology. It goes by all kinds of different names, but it really helps people like you in the plant breeding and seed sector in this age of, what we often call extreme weather. Austin, you have a big interest, like I mentioned, in drone technology specifically. The first time we met, I actually did a podcast interview with you about drones. So you're actually a student at the time. Now, Austin, like I said, you breed corn now at Syngenta. So I imagine that you're working in the field full time. You're encountering a lot of challenges associated, with weather, and those challenges probably really impact your work as it does to anyone, plant breeders who have to work out in the field. Austin, I'm curious, in your opinion, how could this digital agriculture, precision agriculture transformation that we're going through right now benefit people like you, plant breeders, in this age again of what we call extreme weather?
Yeah, it's a good question, Mark, and I hope my mic's coming through okay.
It is.
Good. Yeah, so if I think about the plant breeding pipeline, right, as a corn breeder and what I do, right? So the objectives of our pipeline is really three steps, right? So we create new lines and we test those lines and we advance the best lines forward through our pipeline. So, in thinking about your question on weather and sort of the increase in frequency of extreme weather events, I think it really impacts different parts of our breeding operations, right? So, when we think about the testing phase, so testing our new products, right? With changes in weather, we really need to continually update and make sure that our target regions that we're doing our testing fit and match where our customers will grow those products. So we need to continually update where our target where our target sites are going. Breeders also target sites or locations, farmers' fields. We try to find fields that are really uniform so that we can easily compare our genetics within that field, right? And so with the challenges of weather extremes, finding those big uniform sites is a lot more challenging, I feel, that than it used to be. Finally, once we do our testing, we create new lines, we test them, we have to advance the best products forward. And so we have a lot more data today. We have a lot more unbalanced data today with these new weather patterns. So being able to take all of those different pieces of data together, whether it be weather data or soil data or genetic information, bringing all of that together, visualizing that data, and making the best decisions possible is definitely challenging. And something that we're constantly changing and getting better at, and really excited about where we're at now and where we're moving forward at Syngenta and the way we look and characterize our hybrids. And then to your point on drones, Mark, I mean, I can't even imagine what life was like before drones. Now that they're sort of routine now, the way we use them. Back when I started on them, they were like new tech, and now they're kind of old news almost. Drones are, and really the value of being able to very quickly and very accurately measure our hybrids. It's so valuable to us, and it's allowing us to pick the best of the best to move forward to our customer farmers.
Yeah, well, and extreme weather. I mean, all the data you're able to generate with these technologies, I'm sure, is complicated enough, even without extreme weather events. But then you add extreme weather into the equation, and it makes things even more difficult for you. And so, yeah, I imagine that's a big challenge. Is taking all this data, making sense of it. And I asked him a similar question. And for anybody who's familiar with Arable's technology, Arable's technology looks kind of like a weather station. You set it up in the field, and what it does is it combines weather data, plant data, soil and irrigation data, and then it uses machine learning, AI, and advanced modeling in a single system to sort of help decipher all that and make sense of it. So I was curious to know from Jim how this digital agriculture transformation is benefiting people like him who actually designed this technology. So here's Jim. We're talking today about precision agriculture in this age of what many people call extreme weather. And in your view, how could this digital precision agricultural transformation that we're going through right now benefit an industry like ours, the seed industry, in this age of, again, what many people call extreme weather?
Yeah, great question. And so, I have the opportunity to talk with seed companies, seed breeders, and folks in the space quite a bit. And one of the things that I think is particularly challenging when you look at these changes that we're having in the climate and the more extreme weather that we're getting is, how do we make sure that we're producing seeds that are the right fit for a specific group of growers in a region? And one of the reasons that that's now harder is that's all changing. There's numerous examples where crops that used to grow well in one particular region, that region is shifting north or south, or the rainfall patterns no longer provide the same type of environment for that crop to thrive. And so one of the solutions to that digital agriculture and data can help drive is to really deeply understand what are the specific parameters that drive optimal crop growth for a set of genetics. Right? If we think about the equation of genetics, management, practice, and environment, that environment is now much more dynamic than it was before. And I think a lot of seed companies have the goal of how do we move further towards matching genetics to environment and not have as general portfolios of seeds. And so that can start with getting really good data about exactly what's happening at those trial sites, and really understanding what happened, how big was that rainfall, what were the exact temperatures that the crop experienced during the year, and then starting to be able to use that to understand what the impact on yield would have been, and to cross compare that across geographies so that you can make sure there's a deep understanding of where specific seeds are going to perform well given the new environment that we live in. And so I think that's where it starts, is really having that full complement of data about each place a trial is being done, and then being able to match that to the performance that was seen, and ultimately using that to help farmers get a seed that's going to work really well for the actual weather that they're going to experience, which is, that's making it harder for them out there. And we see that in geographies all over the world. So I think it's definitely a huge challenge for the seed company, for the grower, but also hopefully an opportunity for data and technology to help close the gap and ultimately get farmers products that are really well suited for the challenges that they're going to face.
Yeah, it seems to be a big theme here, Austin, is data and what you do with that. How do you interpret that? And according to Jim, people on the seed side, plant breeding, are gaining a lot of valuable insights from these technologies. I'm curious, Austin, in your experience as a plant breeder, what's one memorable experience that you can relate to us where these digital technologies have really yielded like a valuable plant breeding related insight for you? Is there one particular experience that comes to mind for you?
Gosh, it's such a good question, Mark. And I think about digital technology and what does that really mean? And really, in its simplest form, it's not a new concept. If you think about the advancements in computers and smartphones, auto steer tractors, all those different types of things, digital technology is certainly something that's been around for quite a while. But if I had to give sort of a specific plant breeding example, I'll go back to kind of my graduate school days when I first started working on drones for plant phenotyping and soybeans. So back then, drones were really just starting to unfold and reveal potential for improving plant breeding. What we were able to find in those studies was that the drones could collect data faster and more precisely compared to our traditional methods of sort of going and taking notes by hand. And what this allowed us to do was more accurately and more temporally measure our phenotypes. We can measure once a week instead of once a year. And we could use this data to find genetic associations. So the first genetic associations we were able to find were actually the ones that were already in the literature, which made sense because we're sort of repeating what was done before with new methods. And so that kind of confirmed our hypothesis. But what was really interesting was that we found additional smaller effect loci that had gone unseen before. So we didn't have the resolution in our data sets to find those key important genetic loci that could have an impact in improving that phenotype we were trying to select for. So what we're able to do is see things now that we weren't able to see before to provide sort of new and novel insights. And I think that's some of the power we have now with digital technology.
Yeah, the proof is in the pudding, as they say. I mean, a lot of these technologies, yeah, they're really fascinating. And you think, boy, there's so many things we could do with this. What can we do with it? But then when you have that experience where you actually see it happen, that, oh wow, like this yielded a tangible result, that makes it all worth it, and kind of, brings that down to earth for you as the breeder to figure out, okay, how can we actually use these? And I know Jim had a lot of great insights last week when I chatted with him about some of the real-time benefits that he's seeing out in the field from these technologies, and helping people to deal with weather events and so forth. Here's Jim again. What I find fascinating about digital agriculture, precision agriculture, is the fact that it offers real-time insights out in the field. How could those real-time insights, in your opinion, contribute to improving, say, seed or plant breeding and overall seed performance in this context of extreme weather? Do you have any thoughts on that?
Yeah, absolutely. I mean, I think there's maybe two sides to it, which is one, how could it help manage trials better in the pipeline? And there's examples that we've seen where really understanding exactly when specific growth stages are happening allows to for either treatment to be timed well, or for a drone to be flown at the right time, or just to understand how different hybrids or varieties performed under different conditions. Moving towards the grower side, I think there's a really interesting opportunity at the intersection of seed breeding and digital technology, which is to imagine a future where every seed comes with a digital playbook or a digital recipe that says, as we move through the season, here's what's going to need to happen at this growth stage. Or depending on the environment that's experienced, how much crop water demand has there been during the season, here's how much to irrigate. Here, not when we say here's harvest timing, it's not going to be 70 to 90 days from planting. It's a digital product that will predict it from the beginning to the end of the season, and that can help growers manage generally, but can also help them manage in a genetics specific way. And that absolutely requires this real-time data, because a digital playbook that's static doesn't really match the realities that the farmer faces. Every season is different. and how prevalent is disease risk going to be in the mid-vegetative stages? Well, that depends. How much nitrogen do I need to apply? That also is going to depend on how much rain you got after your first application or something like that. And so I think all these things can come together, and I think we've seen it before in this industry when you pair up sort of the genetics and seed side with some, in the past it's been physical product that happens out in the field, and in the future, and I think starting now already, that's going to be digital products that get paired with the genetic side, and together that can create a product that can achieve higher yields, be grown more profitably, and ultimately perform better in a consistent way. And that helps everybody.
That's fascinating to me, Austin, the thought that we could pair seed with digital technology. Like I know right now we pair seed like with seed treatments, seed applied technology, where you take a seed and you put treatment on it before you put it in the ground. But this idea of pairing seed, these literal genetic products with like a piece of digital technology is not really something I've really ever thought too much about before. And how might that work in the real world, do you think? Like, do you foresee a day where that might come, where we might go beyond, say, just pairing like seed treatment with a seed, where there's actually like some sort of digital machinery or a product that you pair with it? Like, what do you think of that?
Yeah, this is a great question and a good point. And so I think the best example I can give is going to my father's family operations on the farm. And so I grew up on a farm. My dad still grows corn, and basically when he buys a bag of seed, he's getting so much more than just a bag of seed, right? So he's getting recommendations on what are the best list of hybrids that I can grow on my farming operations, but also within those, what's if I have this piece of land that is higher productivity, then I might recommend hybrid A to that piece of land. Hybrid B might respond differently to different planting densities than hybrid C, and maybe hybrid D has a better tolerance to a certain disease, et cetera, et cetera. So when it comes down to matching, it really comes down to matching all of that data that we collect internally at Syngenta, getting the digital piece out of that and using it to make recommendations for farmers so that we can maximize yield potential and ultimately profit. And back to what the other person on the call said, it's G by E by M, and really dialing in and using all the data we have, all the digital data we have, to get that M component, the management component of this is the best hybrid to grow on this acre of land. And that's what's really going to be the key moving forward and maximizing yield potential and ultimately profit.
Yeah, there's so many possibilities, and I know I always like to end these episodes on sort of like a futuristic note, and so I wanted to ask you, if you had a magic wand, what piece of technology would it be? What piece of digital precision agriculture technology you would create if you had that wand and could just wave it and summon it up? So take a moment to think about that. I posed the same question to Jim, and so I'm going to play that now. And then, yeah, after we hear from Jim, think about which one piece of technology, Austin, that you would dream up if you could wave that magic wand. But here's one final comment from Jim. Is there one thing that, if you had a magic wand and you could say, we're going to make a technology that's going to help the seed industry this way, and all you had to do was wave that wand and boom, the technology was there and it worked and it did a great job for everyone, what would that one technology be?
That is a great question. I mean, I mentioned I love the idea of on the farm for the farmer customer, bringing together the genetics and the digital side. The other one that I would highlight, if I had my wand out with you, is to be able to create a full digital replica or twin, as it's sometimes called, of any trial site or plot. And so I'm able to model exactly what's happening there in the digital world and extrapolate and project and say, okay, given what we knew here, here's what should have happened. And now how do I fit the genetics into that equation. So sort of a comprehensive model of the crop's growth and expected growth and what's driving it all through the season, from the soil to the plants to the genetics to the farmers' practices. And so that sort of full mirror of the real and physical world into the digital world, I think would open up so much in terms of the way that we can build new seeds, the way that we understand them, and ultimately help accelerate that timeline, which, as we know, is oftentimes 7, 10 or more years to get from the beginning to the end. We could make that, maybe 5 years if we had that type of power and capability, which I think would only accelerate, the development of new crops that can help mitigate these risks from extreme weather. And so I think there's a lot of really interesting and valuable new innovations and developments that are going to come out of seed breeding and genetics in the next 5 to 10 years, and we need them. We're going to need them to be able to meet the challenges that are facing agriculture. And so the idea that we could make that go faster by quite a bit, and I think that's possible if we were able to snap our fingers and get into this world where data, and not just data, but all of the other technologies that go behind that, machine learning, AI, could be fully brought to bear into what folks are out there trying to do every day, which is build great products for farmers and understand which ones are going to be most effective, where and when and for whom. And so that full digital twin experience with predictive capabilities, I think, would be really groundbreaking for the industry.
That almost makes me think of, what someone like Mark Zuckerberg would call the metaverse, where you've got like this. I don't know if you're a Star Trek fan, but they had like the holodeck where they could like literally step into another world. It's like a simulation, and to think that you could have that out in the field, like like a simulated field that you could go to and have different scenarios and see how things perform in any kind of weather conditions. And boy, I'm sure that would be something. What about you, Austin? Like if you had a crystal ball or magic wand, you could say, I want this piece of technology that would just like be a total game changer. What would that be?
Yeah, I think if I had a truly magical wand, I'd probably use it to predict the weather forecast. But I think that's a little bit outside the scope of what you're asking. I would also wish for all environments to be the same, so that like the hybrid that I created when I tested it on a certain environment, it's always like that. But it's not the case. But I don't think there's a silver bullet here to plant breeding and the seed industry. I think what I've been seeing is that the seed industry's been sort of moving in the right direction. I think it's generally investing in technology with the grower in mind. And I think that's so important. I think artificial intelligence, AI, is sort of transforming the way we think about our processes. And I think that technology will continue to evolve. I still think plant breeders are relevant for interpreting and using the data, along with getting boots on the ground for seeing our new products and genetics out in the field, out in the farmers' fields. I think that's so important still. But I do think AI and other data software platforms are going to sort of change how we think about our processes for sure.
Well, an AI builds on human knowledge, right? I mean, AI is useless if you don't have that foundation of human knowledge that it can learn from, and you have to keep injecting the AI with fresh knowledge so that it can keep learning. If you don't have that fresh knowledge, those new insights from human beings, then the AI is kind of stuck. And then I would think that it's the AI itself is just left. The machine is just left kind of having to learn from itself, which I'm not sure would be all that valuable. And so, yeah, I think you're absolutely right. This idea that you keep hearing that AI is going to replace human beings and all this, it won't. It can't, because AI is nothing without plant breeders like you supplying it with those new insights, that new knowledge. So yeah, I don't think anybody has to fear AI too much. It's not going to be replacing us anytime soon. I don't think, anyway. Thanks so much, Austin, for your time today. It's been great having you on, and it's been good to see you again. And
Yeah.
for since 5 years ago. So thanks so much for your time today.
Yes. Thank you for having me. This is fun.
Yeah, it was. And thank you to our audience for taking some time to out of your lunch hour to join us today. That's all the time we have on Seed Speaks this week. I would like to thank Austin and Jim as well for taking the time to talk to me last week. Next week, our host, Ashley Robinson, will tackle the topic of using weather forecasts to grow crops. This is Mark Zinkowitz of Seed World Group signing off. Have a great day, everybody.